So the recording is on. Hello and welcome everyone to the first SQL Lightning Talk Friday. It's SQL Friday number 87 and we never had lightning talks before. So it's going to be fun. We'll see if the technology is with us. I think it will be. We're used to Teams. Each of the speakers will have 10 minutes each. And the speakers today is Zoran Barach, Erland Sommarskog, Ed Pollack, Tayob Ali, and Rachel Eskens. And they will each present their session titles as they start. So first out is Zoran. Are you ready?
Yes, I'm ready.
Good. And there is not going to be any question and answers. So because 10 minutes, that's a short time.
Yeah.
So I will just pick out a timer. And the stage is all yours, Zoran.
Excellent. First of all, I would like to say thank you to Magnus for organizing SQL Friday events. I know how much time you need to involve in this and how much effort. And it's running since May 2020, so it's great achievement. I'm going to talk today about the Azure Load Balancer role and what role has in setting up the VMs infrastructure as a service on SQL Server Always On Availability Group. My name is Zoran. I'm a speaker, blogger. I have an Oakland SQL user group. I'm organizing that here in Oakland, and all welcome to join us. Let's move on. So this is agenda for today. Since I only have 10 minutes, I cannot really invest enough time in each one of those options, configurations we have. I'm going to scratch the surface for some of them. And we're going to talk about the most common mistakes you can do when you're setting up the load balancer for Azure SQL. For VMs on the infrastructure as a service. So this is the Azure Load Balancer first page showing us like which types we have there. We have two different types: internal load balancer, which is balancing the traffic within the same VNet, and external load balancer, which is balance the traffic from the internet connected to the endpoint. In this case, and first of all, I want to apologize as well for talking a little bit faster, but I have only 10 minutes, so I'm trying to squeeze in. I hope you guys are all gonna understand me what I'm saying. So we have two of them. I'm going to talk about private internal one mostly because I don't like exposing my SQL Server instances to internet anyhow. So we're going to talk about that, and we're going to talk about SKUs if you have a standard and basic SKU. But before we start with that, we just want to say there is option. You can set up your always on availability group on Windows Failover cluster on Azure VMs, even without the traditional virtual network name, VNN availability group listener. You can go with the DNN, but then you need to think about the unique ports, and you need to think about multi-subnet failover to be true and connection string and how that works, how to set it up, and so on, so on. But we're not going to go to there. We are talking about load balancer. So here you can see the standard and basic one. What is the difference for a production workload? I would definitely suggest standard one because you can choose for backend type for your VMs. You can choose IPs as well. So the second one, backend pool endpoints, really important because you can actually use the VMs from different multiple availability sets. Availability sets really important, setting up the always on VMs on Azure because it's actually covering your concept of file domain and update domain concept, which is really important. Then you have availability zones, and this is, just bear in mind, this is not the only difference between the standard and basic. I'm just covering the most important one, and as much as I have time. So you have availability zones. It means that you can choose zone redundant for your data path. You can use zonal, which you use the preferred zone for your endpoint, front end and endpoint. You have a private link support, so you can actually create private link access to access with different VNets. And at the end, you have cross-region load balancing as well, which is kind of enabling the geo-redundant scenario there. So there is a four really important configuration part when you're setting up Azure Load Balancer for always on. It's a front-end IP, back-end pool, health probe, and the next slide is going to be load balancing rule. Front-end IP, it's one of the most important part of it because you need to redirect the traffic to the front-end IP at the end because front-end IP is going to have exactly the same IP as your AG listener. Backend pool, you can see here I have two VMs there, SQL 4 and SQL 5. Those are going to be your VMs living in a backend pool where you're going to redirect the traffic. And I'm going to show example, having that for always on and having that for a traditional load balancing. Then health probe is actually your heartbeat. So all those healthy ones, healthy VMs in the back are gonna get the traffic. So this is the load balancing rule. Load balancing rule is actually used to define how incoming traffic is distributed to all instances within the backend pool. But bear in mind, for what we are doing in always on, we don't want to do that traditional balancing. We want to redirect our traffic to front-end IP. Front-end IP is our floating IP. So that's the you can see in this second part of this slide is actually about the floating IP. So when floating IP is enabled, Azure actually changed the IP address mapping, and instead of going directly to the instances you have in backend pool, it's going to directly go to that front-end IP, and that's your listener IP. Then you have a session persistence. This is very simple. You should put as none because you want that any success request can be served by any client in the backend pool. Any client can be served by any virtual machine in the backend pool. So this is how that look like when you're using the load balancer insight. So this is pre-built monitoring dashboard in Azure portal you can actually use and see if you have any issues with your settings. So in this case, you can see that SQL 4 and SQL 5 both are not available. And bear in mind, you can't use the ICMP port protocol. So it's not permitted to ping directly the load balancer. You need to ping through the port. So you need to specify the port during pinging. You can use the telnet. I personally use the PS ping tool. And I put my listener name and I just add the port in the back. So in this case, you can see it might be some potential probe health port misconfiguration because they're not getting the health response from both of machines. And it can be firewall issue, can be VMs not accessible for any reason. It might be, for example, that VMs are shut off or something like that. So VNets issue, anything like that can cause similar like this. Again, this is both available. You're not looking that one as well. This is how the traditional load balancer is actually working. It's load balancing the load to all machines which are healthy in the backend. So in this case, if you have like probe health port misconfiguration, what does that mean? You might using the port which is used by some other process, and then both machines are available. So that means that your traffic is going above, but you know that if when you have always on availability group in Windows failover cluster, you have your listener, just the primary can handle that load and should handle that load. In this case, you can end up you redirect your traffic to the wrong VM in the back, and you're going to have a similar error to this. So if you fix the probe health misconfiguration, you might end up, okay, now I have the SQL 4 as a primary and SQL 5 as secondary. It's fine because this one is handling the listener, but in this case, you can see that floating IP is not enabled yet. So your traffic is going directly to the VM IP instead of the front end IP. That's your listener. So to fix that, you just need to enable the floating IP, and then you're getting what you should get. Bear in mind, but I'm not going to tell you how to configure the Windows failover cluster and always on in the back and all the rules. You basically need to set all the cluster parameters on the VM itself for a Windows failover cluster, for the AG listener, and so on, using the PowerShell. It's much the easiest way. And you need to pass those cluster name, IP address of the internal load balancer, which is your listener, and the ports, and so on. So how that actually look like is this. So once you do that, you have two machines in this case, and you can use the netstat and see what is actually listening my 549. That's my health probe, which is kind of like default, which Microsoft is suggesting, but you can use any, but just be careful that nothing else is using that port at the time. So in this case, what you can see, you can use that there is a RHS.exe process, which is mapping that port and listening that port. What is the purpose? But basically, that's resource hosting subsystem. And we can say that is the process which helps internal load balancer identify which cluster node or which instance in this case is the primary replica. So that's really important. Since 2008, Microsoft is using this, and it's kind of preventing the resource get crashed from and being more available because it's kind of like grouping the DLLs in the back for this particular process. So you can see here you have a process ID 236, which is attached to failover cluster resource host subsystem, and it's actually listening our 549 port because that's our primary. If you run this netstat on a netstat command on a secondary, you're not going to have anything listening there. So this is when failover happen. You have a SQL 05 here. Here's the primary, and all the traffic, because you have enabled floating IP, all the traffic is going directly to the SQL 05 instead of to the IP. It's pinging directly to the listener, is actually accessing directly to the listener. And you can see there is a process ID 8600 in this case, which is holding your failover cluster resource host subsystem and mapping to your port. So this is your primary, your internal load balancer exactly knows what to do and how to do it. This is just how it looks like. If you go to SQL 04 now and run the netstat and try to see what's listening to 549s, you're gonna get nothing. So that's how it should look like. It's not the traditional load balancing with both those machines or 3 or 4 machines available. Just the machine which is holding the listener, which is the primary, should be available, and all the traffic should go there. I think I managed to fit in 9 minutes and something.
9 minutes 55 seconds. Excellent timing.
I hope you guys understood me, because this was fast.
It was. It's a lot of information, but it was good information. So thank you so much. Applause are coming, and hearts even. Let's see who is next up. It's Ireland, right?
Yeah. So I'm going to share my screen and going to get rid of. See us going to move over. So, okay. So, who's starting the timer?
I'm starting the timer now. So stage is yours.
Welcome to this session about using regular expressions in Python from TSQL. So my name is Alan Sommerskog, and if you want to get in touch with me, my email address is sql@sommerskog.se, and on my website sommerskog.se/present you find the slides and script for this session. So I'm going to start with looking at a problem. To the left, we have some comma-separated lists, but you may notice they're kind of messy, because sometimes there is no space at all after the comma. Sometimes there are double spaces, and sometimes there are double commas. Now, what we want is nice, pretty comma-separated lists with exactly one space after each comma. Although if there are double commas, we want to keep those, but we still want one single space. Now, how will we do this with pure TSQL? Well, we have like and Pythonix, but they support only very simple wildcards. And how will we express things like, okay, 0 more spaces? We don't really do that. And replace can only deal with fixed strings. Now, so you might feel, if you know regular expressions, this is what I want. And for a long time, we have been able to do this with the CLR using the regex classes. However, if you're not already using the CLR, it comes with a bunch of red tape. So therefore, it's interesting to look at alternatives, and in SQL 2016, Microsoft introduced their machine learning services that permits us to run scripts in other languages. Originally, the only supported language was R. In SQL 2017, came with support for Python, and 2019 added Java, and also they exposed the interface. You can add your own language. We're going to work with Python since that is a very popular scripting language. Now, to be able to do this, there are some preconditions. So you need to have Python installed on your machine. And that is, or on your with SQL Server, and that's an optional install. So when you run the setup wizard, you need to check the machine learning services in Python, and you can add this afterwards. Later on, or the next step is you need to configure the server configuration parameter external scripts enabled, and you need to assist them in to do that. And finally, the user who runs the whole thing needs to have the permission execute any external script. Now, so how are these executed? Well, you call this the procedure execute external script, although that one does not run the Python itself. What it does is it passes the input data to the launchpad process that actually executes the Python scripts. So runs in a process separate from SQL Server, which means it's very secure. They can't do any harm to SQL Server. And also, by default, the launchpad process has very limited permissions in the operating system. So now let's have a look at that example that I showed initially. So first of all, I'm just going to enable external scripts so I can use them. Then I'm going to create a table here called play data. Then I'm going to populate with exactly those comma-separated lists I had to the left. And then here is the actual solution. So here's the Python script, and I'm going to explain this a lot more on the slides later on. And here's the call to execute external script. And I'm going to run this, and now you will find that, yes, it's going to take a little bit of time. It's going to take some time because the launchpad process is not running, so SQL Server has to start it, and also this runs on a VM. So this is where I get a small lag in my session. It's going to take a few more seconds, but until we have the results. Yes, here it was. And you can see now exactly one space after each comma. Now, in real life, maybe I think I wanted to actually clean up my data in the table. So how would I do that? Well, you would simply receive the results from execute external script with insert exec. So I create the temp table that receives ID and text, run that, and then I do the update, and I run this again. And you may notice now I got the result a whole lot faster. And I didn't run forgot to run the final one. So you can see that I actually did update the table. Now, so what actually is going on here? Well, so this was the heart of the matter. This is the Python script, and this is the call. And let's start with looking at the call in more details. The first parameter specifies the language, and that's Python. The next one is called @InputData1, but don't be fooled, there is no @InputData2. But it specifies the data set you're going to send to the Python script, and it's simply a select query, which is going to be executed by this procedure and then passed to the Launchpad process. Next parameter is @InputData1 name, and that specifies the name of the Python variable that is going to receive the input data. And the next one specifies the Python variable that on the output has the final result. But as you can see, I can use the same variable. And the last parameter is the script itself. Now let's move over to the Python script, which is only 2 statements. And the first statement, it's an import statement that imports 2 packages that we need. RE, that is the packages for regular expressions. And pandas, well, that's a general, very complex package for machine learning and things like that, for data frames. And that is also what SQL Server uses to communicate with Python. Then we have the next statement, and you don't really have which falls into 3 parts, and you don't really have to understand the first and last part. We can consider this as some kind of mumbo jumbo. But so this was the data. That's the data I have specified here, and that's, well, it's the same variable, but also specified here. That's why I get the output result. This is a dictionary, as it's called in Python, and it's keyed by the column name. So that's how I address it. Then the middle of this is the call to resub, the one that actually performs the substitution. And it takes 3 parameters, of which the last one is the input variable with the actual data to replace. And it's defined, this variable is defined down here in this list comprehension and reappears here. Now we come to the really hot stuff with the regular expressions. So what I'm looking for is a comma, followed by 0 more spaces, and then a word character that is either a digit or a letter. And then I'm going to replace this by a comma followed by a single space, and this \1 maps back to this word character thanks to these parentheses that defines a group. Now, one thing I like to call out here is also this R before the character strings. This is how you mark what Python calls a raw string. If you don't have these R, Python are going to gobble up these backslashes before they get into resub. So when you do this, always put in these R as a habit. We're going to look at one more example. So to the left, I have some names: Big Business Incorporated, Mary Jones Senior, etc. And all these have titles or other suffixes that we want to get rid of. And I have defined those in the table. And I have to be careful because DR, I can just not do simple replace, because in English drinks, I want the DR to remain there. So let's have a look at this. Now, what's going to be different this time is we're going to pass the regular expression as a parameter to the Python script. So first, I'm going to set up the tables. That is the tables I have the titles here are the one I want to replace, and then I got the input data. Now, then I'm going to do here, I'm going to form a regular expression, and I'm going to describe this more in a second. And here I'm going to run the script, and you might notice there are 2 more parameters, and I'm going to run this, and you see now, and yes, this time I got back 3 columns. I'm also going to explain this in a second. And you can see here, Big Business Incorporated became Big Business, etc., etc. So first of all, I formed this regular expression by using the string egg function and joining it. So I'm forming one regular expression per title, and then I'm uniting them by the pipe character, which stands for alternate. So my regular expression is going to match any of these. And the regular expression is 0 more spaces, followed by a word break, the title itself, another word break, and a period. I need backslash to escape that, to not having the period having a special function, and 0 more spaces. And here I'm passing the parameters. So I define a parameter list in the same fashion as with SPQ SQL. So I give the name of the parameter, and because here I have to specify an @ character, but I don't do it up here, of course, since I don't use that in Python. And this is the actual parameter. And beware, these 2 parameters or any other parameters you have, you must come at the end, else you will get interesting errors. Also, beware that resub is by default case sensitive, and I want a case insensitive search here, so I can pass an optional fourth parameter to specify here with ignore case. And this is how I achieved that last column. I simply put in a different key name rather than reusing full name. That's how I got third column, 3 columns. And so my name is Alonso Musco, and you find slides, and here is my email address again. You find slides and scripts on my website. In that script, there are 2 more examples, a little more advanced. Here are some links to get started with using Python in SQL Server. This link here is linked to the RA packages, so you can learn all the details about regular expressions. And if you want to learn everything, here's a link to pandas. But I only glanced at that page myself. You don't really need to know it. Thank you very much. And did I make it on time?
You have a full minute if you want to add some more.
Oh God! Then it went too fast. Oh well. Now I think I should not try to improvise. So yes, it's gonna get back.
Well done, and I will look at your scripts later because I mean this must be the most asked for feature in T-SQL. Implement support for regular expressions.
Yeah, that's one of these. Every once in a while you run into these problems, and this is, well, if you really have large data volumes, like you have a terabyte table, the CLR will be better because it's going to hurt. It's going to send all that terabyte data to the Launchpad process. But the CLR, you can take 1 row at a time. But it's a lot leaner solution than using the CLR.
Yeah, and I think when CLR was introduced in, was it SQL 2005?
Yeah.
Regular expression was the first example that Microsoft talked about, and I'm still like, but why don't you just implement it in T-SQL so I don't need to enable external scripts or enable CLR, whatever. But
yeah, lots of things they could do.
I gave up a long time ago. And next up is Ed, who is going to explain column store index compression in a nutshell in 10 minutes.
Everything look good?
It does. Are you ready?
Yes, I am.
All right, stage is all yours. I start the timer now.
Great. Thank you very much for having me here today. If anybody talks about column store indexes or you read about them, you just get the idea that compression is probably the #1 reason why they perform well, and it is. So this blast through session here is going to be all about how it works and why it's so good. First off, here's me really quick. I've done a lot of speaking, writing, a lot out there. Feel free to find me on Twitter if you have questions or any thoughts, ideas, or want to just chat. We don't have time for that, though. We're here to talk about column store compression. Here's our agenda. Brief review. How does it work? Why is it important? 5 seconds left. I breathe again. We're done. So how do column store indexes store your data? First off, they break it into row groups. A row group is up to 2 to the 20th rows, about 1 million rows. The index can have as many row groups as is needed to store the data. If you have 1 billion rows, you'll have about 1,000 row groups. Within each row group, the data is broken into segments, 1 segment per column. So each column is compressed separately from all the rest of the columns within each row group. Therefore, the number of total segments you have within the column store index is going to be exactly the number of columns times the number of row groups. Great. This is really meant for OLAP data. If you're using column store indexes, it's really, really meant for data warehousing data, for analytic data. If you use it for transactional data, it's going to kind of stink. It's not really meant for that. So how does column store compression work? Step 1 is you're going to compress segments. The first thing you have to do is transform your data into a format that is more easily compressible. You have lots of repeated data. How do you manage that? So there's many common methods towards how you encode your data. The most common ones you'll see out there in column store indexes and also just elsewhere in the world are dictionary encoding and value encoding. And all these algorithms are lossless. They can be decompressed, no problem, back to the exact way they were originally. And a beautiful thing about SQL Server is when they created column store indexes, they gave us lots of views to see how our data works. sys.column store segments, sys.column store dictionaries are wonderful references to tell you exactly how your segments are compressed, how the data is stored, and how it even looks. That metadata is used to optimize your queries and make column store indexes even faster. Let's give an example of what encoding looks like. So this is called dictionary encoding. I have a yummy data set here of desserts. And this is my table. It can be many more, it can be millions, billions of rows of cookies and things. And that's great. So there's my values on the left and the size in bytes, assuming varchar, not nvarchar. And the total size for all this data here is 203 bytes. That's my data set. It's not compressed at all. So uncompressed, 203 bytes. So the first step in doing dictionary encoding is to create a dictionary. The dictionary is essentially a row per possible value and then an index ID. The index ID will be of the data type that is smallest, that can just fit in exactly what you need. Here it's going to be 3 bits. That's all I need to store this. So I get a row per dessert. 5 distinct desserts, 5 rows in my dictionary. The dictionary size in bytes is 82 bytes. So now I have my original data and I have my dictionary. Now I take and I go one step further and I encode my data using the dictionary, and I replace all those original values with index values. So what I end up with now is a set of index IDs that map to the dictionary. The dictionary encoding requires a dictionary and the encoded data. My end result here is that I have a dictionary that costs me 82 bytes, and I have a encoded data set that costs me 33 bits, about 4 bytes. So about 86 bytes down from 203 bytes. That's really impressive. And so this sort of dictionary encoding is great for values that repeat over and over and over, especially like ones that are a little wider. You can crunch them down, and now you have to have this tiny little index instead of a big honkin' dictionary value. Great. Once you have encoded your data, whether through value encoding, whether through dictionary encoding, or some other form of encoding, this is a really critical step that's not really talked about a lot in SQL Server, but it's very, very important. That's optimization. Within every row group, the order of rows doesn't really matter. All that matters is that it's in that segment. Column store indexes preserve the order you provide them, but they don't have to keep the data within each row group in order, and there's no clustered row store here to force an order. So optimization reorders rows. In SQL Server, it's called VertiPack optimization. You can check in the segment metadata, in the row group metadata, to see, is it enabled or not? Does it exist? Does it use it? And you want it to be used. It makes a humongous difference in compression ratios. It'll generally improve compression by at least 20 or 30%, even possibly more. Here's an example of optimization. This is my encoded data from earlier. It's all nice and compact, 33 bits, but it's out of order. 0, 1, 2, 3, 4, 2, 2, 4, 2, 0, 0. Totally out of order. All optimization says is, hey, if this data is rearranged and put in order, it'll be easier to compress later on, and it will be. So we're going to take it now and just turn it into 0, 0, 0, 1, 2, 2, 2, 2, 3, 4, 4, done. Takes the same amount of size. Optimization itself will not conserve any space at all, but it'll reorder your data so that compression further down the line will be more efficient. Great. Last step involved encoding, optimization, now the actual compression is where we apply traditional compression. When you think of zip or anything like that, compression algorithms, this is basically what we're doing here. X velocity is used for column store, express is used for column store archive. These algorithms are relatively proprietary. There's some information out there on how they work. Good luck digesting that, but you don't really have to know how these things work in order to use them. The goal really of all these compression algorithms is to take repeated byte patterns and then group them together. If you have the same characters or character expressions or groups over and over and over, you can represent them with a smaller expression, which is a nice mathematical simplification, and it's very effective. For example, let's say I apply run length compression to our existing data that we've already worked with. So we have encoded it, we have optimized it. Now I look at my data and say, I don't have to have 0, 0, 0. I can have 0 3 times, 0 subindex 3, 1 index 1, 2 index 4, 3 index 1, 4 index 2. And so now I'm shrinking down my data further. Now this is a very small data set. I only have what, like 10, 12 values. In a large data set that has millions of rows, billions of rows, when you have a full segment of 1 million values, this can compress down a lot because values repeat a lot within one column. That's the beauty of it. Run length compression is wonderful for sorted data that you can optimize, but what if you can't sort it and optimize it? You can do bit array compression. Bit array compression says, hey, we'll create a hash table of all the possible values and then pop ones and zeros in wherever there's values. That array at the top is kind of expensive, but once you've done that, it's kind of like what we did earlier with the dictionary, kind of on the fly. And now storing ones and zeros, as we all know, is very inexpensive. Bit array compression is wonderful for unsorted data. Great. Now we know how it works. Kind of. We did it in like 5 minutes, but we have an idea how it works. So how can we optimize it? First off, SQL Server cannot use VertiPack optimization for new data inserted to a clustered column store that has non-clustered row stores. If you have non-clustered row stores and a clustered column store, VertiPack will not automatically apply to new data. You need to find a way to work around them. How you work around it's really up to you. I've written articles and books on it. Feel free to look them up. In addition, memory optimized column store indexes, a very awkward structure you may or may not want to use, but if you do use it, it's not going to optimize or compress as well as you think it will. Always test and determine is memory optimized makes sense for this. It may or may not. Last but not least, dictionaries, if using dictionary compression, it'll be indicated within segment metadata, are limited to 16 megabytes. That's it. Otherwise, if you hit 16 megabytes in a dictionary, your row groups split up automatically. That's not good. You want row groups of 2 to the 20th, not row groups of 10,000 or 100,000. So what happens when this occurs and you see that you have dictionary pressure? Take wide columns, it's usually the cause of it, and normalize them. Normalizing very wide string columns, decimal columns outside of the table into their own tables, then having your column store index have the nice compact indexes referencing that data will then allow it to compress a lot better. No dictionary splitting, better compression, better segments. Therefore, also on the opposite flip side, normalizing narrow or repetitive columns that are just bits or small ints or whatever will probably waste resources because dictionaries will gobble that up happily and spew back what you need, beautifully compress. So normalize wide columns in a column store. You don't have to normalize very narrow columns if you don't want to. Great. Let's wrap up now that we've spent like 9 minutes on this. Compressing by column gives you amazing compression ratios. The data within a single column is going to be very similar, whether it's a status or a type or whatever it is, or an ID. There's going to be a lot of repetition in there. That repetition makes for amazing compression. That data isn't just compressed on disk, it compresses in memory as well. You read pages into memory and it's still compressed, meaning you save disk, you save memory. You can tweak the compression in some of the ways that I showed here, or in more ways that are available out there that I've written about. Feel free to look me up. And last but not least, if you need to understand how these things work, there are lots of dynamic management views that provide complete transparency into how your row groups are structured, how your segments are structured, and how your column index, store index works. Therefore, you can learn about it and then make changes based on that metadata. That is everything I have. There's no questions here today. Obviously, it's a lightning talk, so ignore this slide, but it does have my contact info if you want to find me later. How do we do?
9 minutes, 54 seconds.
I have 6 seconds left? Oh my God, I failed. I'm just kidding. It's all good. Thank you very much for having me. I appreciate it. I hope you enjoyed this. Questions, please let me know.
There is a question in the chat, but Gabrielle, who asked the question, either stick around for when all the speakers are done, or just poke Ed on Twitter. He'll be happy to answer, I'm sure. Next up, oh, thank you, Ed, for an excellent 10 minutes. Tayob, are you ready?
Yes, I am. Let me share my screen. So yes, I'm ready.
So notebook jobs, end-to-end demo. The timer starts now.
Okay, thank you, Magnus. And a shameless plug, I'll be here next week, same time for a full-length session. So look it up. If you're here today, hopefully I want to see you next week. And that's a back to basics with checkpoints. So I'll be talking about notebook jobs, and the tool I'm using is called Azure Data Studio. I do not have any slide. I'm using something called Jupyter Notebook in a SQL kernel. But if you do not know what's a notebook and you are working with data platform, data engineering, operations administration, I'll highly encourage you to look up. There are excellent sessions done by community leaders and also by Microsoft employees. You definitely want to get used to notebooks. I'm not going to read the abstract you probably read. In order to use this, there are a couple of prerequisites. Definitely, you have to have a Jupyter notebook that you want to run against your SQL Server. And there are 2 extensions. You can use either one because the admin pack includes SQL Server agent extension. Admin pack actually come with 4 different extensions. And you want to pre-create an agent job schedule and select a database to save metadata. So these are a few things you have to do. Now, why do we need to do this? Like historically, we've been using SQL Server agent to manage our jobs, but we didn't have notebook before. And if you have a notebook and you want to schedule a notebook, this is a good way to do it. And what's the advantage, right? And if you know about notebooks, say like you have a crisis in the middle of the night at 2 a.m., right? And your team all have the same notebook to troubleshoot, or you want to capture some information, right? Before you solve the problem, because the next day morning, the question will be, can we get a root cause analysis, right? And you'll forget what you did at 2 a.m. So you just run the notebook. If you already have it set up as a job, you can just go and say run the job as a one time. You also get output, which you'll see as a notebook. So you have everything. Then you make your changes, you solve your problem, you run it again. So the next day when you come to work, you can open both notebooks, compare it, contrast, and see what you change. You have to designate a database to hold the metadata. What does that mean? So there's two things. One is the definition of your notebooks, which is nothing other than a JSON file, and your runtime stats, right? Which one failed, how long it ran, and all that. And these are the two tables get created. So in my example, I am going to just create a new database, right? So I will connect to my default instance. And you can use the existing database, doesn't matter. And I'll show you where you can do this. Now, creating a notebook job has a couple of steps. I'm not going to go read all this. I'll show you in the demo, but if you want to read about this, go to this URL and you can read more. I just put a one-liner description. Now, if I already have a job, I want to delete that so I don't get an error message. And run a notebook job. So now we're going to go and show you how to do this. So I'm going to go to my default instance. Let me close this. Now, whatever you see here, most of these are coming from extensions. And I'm not going to go into details, but if you click extension, you can type, you'll see all kind of extensions here. So like the one that we've been talking about, I can get SQL Server Agent. This extension is actually creating this. Now, if I open this, I see that this is a job that I will see if I open my SQL Server Agent properties. If I go to notebook, I do not have a job, right? So let's create a notebook job. I'll give the notebook path. And don't worry about what this notebook is doing. The concept is if you have a notebook, how do you run this? Storage database, we create a notebook job. So I said you can designate an existing database. I just want to keep it separate. And since I'm collecting the server configurations, I'm just going to run it against a master database. And the job name actually takes the notebook name. But if you do not like it, you can put your own name. One thing you cannot do, you cannot create a new schedule. So you can pick your existing schedules, but if you want a different schedule, create that first, either T-SQL, PowerShell, GUI, whatever you want, then it will show up here and you pick up and you can give a description here, SQL Friday demo. Now we see that we have a job here. And if you go to your SQL Server Agent, you will see the same thing. Okay. Click this. Of course, it's a new job. We didn't run it, so I'm going to run this now. It says the job was successfully started. Refresh it. Here you have. So the job ran. The beauty of this is now I have a separate notebook with my date time stamp. Right? So you can schedule this every week, every day, certain time. So you have a history with the output and everything. Now I have the result set here. And I can send it to someone. I can send it to my team. I can go and open it the next day. If I have a crisis, I have a troubleshooting notebook, I can just run it without thinking. So the data, so everything is safe. So where is this notebook actually? If you go to it's actually saved here. So if we go here, replace my username. Right here. I can take this, save it somewhere, attach it, send it to someone. So I told you that I need a metadata database, right? So what happened there? So let's take a look. There's two things. One is the definition of my notebook, and another one is a job history. How long it ran, what time I ran this and all. Now, behind the scene, it uses invoke SQL command, so it doesn't work for named instance. So I gave you a couple of examples. And if you say, no, I don't like all this, I don't like Azure Data Studio, can I just schedule this from my SQL Server agent as a PowerShell? Yes, you can. I gave you enough, couple of examples. This is for a default instance. This is for a named instance. I'm getting an error into open editor file. I don't know why. I sent it to two experts this morning. One is Rob Swell and Aaron Nelson. Hopefully I'll get answers soon, and I'll modify my script if I need to. But you can open it manually or you can open it in a different way. This thing still doesn't work for Azure SQL Database the way I showed you. If you want to run this against Azure SQL Database, I gave enough command here that you can take this and use my code. So let's try one of this. Take this. So I'm just going to take this out. Force is going to see if I do not have an out file name, it is going to override, because by default, if you run it like this, it goes to the same folder where you have your notebook. And as you can see, we ran this. Now, if we go to that folder, notebook jobs, and you'll see that I have a right now 6:41 a.m. is my time. Now you can take this and put it in a SQL Server agent job as a PowerShell type. And you can schedule that from there also if you do not like what I did here in case. And I also put some references if you want to read more about this. And these are my contacts. So I think I'm done with my timing. I do not see any question. It actually answered the previous question. Will you share this notebook? Oh, I actually, it's a good question. I actually have that ready to put in the chat. I didn't want to put it when Ed was talking to get, yeah. So you can download this from GitHub right now. All these, two notebooks and the one that I'm presenting, and the notebook that I'm running as a job really doesn't matter. Just a very simple one example. You can put any code you want, whatever you need. So yes, you can download this right now. Give me feedback if you find anything. Share it, use it, give it to your colleagues. The more people know about it, I'll be happy about it. So yes, you can download, and I'll keep this updated once I find what the problem is with the opening the notebook directly from the command line. I sent it to two experts. I'm sure they will know. They're a lot smarter than me. So Magnus, I'm done. Thank you.
Thank you, Tayob, and excellent timing from you as well. I'm impressed by all of you. I've done lightning talks, and I never finished all the things I was supposed to talk about. So I always had to skip like the 2 minutes in the end. So, perfect. Thank you so much.
You're welcome.
And I mean, don't worry about the shameless plug. I like it. So I also posted the link to the next week's meetup where Tayob is doing a 60-minute session. So last but not least today, and definitely not shortest, is 2 meter DBA, right, Eskens?
Yeah, I'm supposed to live up to my Twitter handle now.
Are you ready?
Really big footsteps. I've got to follow in today, so it's going to be an exciting run. I'm
starting the timer now.
All right, let's get this one going. I'm going to talk about today. I'm going to talk about hyperscale and a few things I'm going to cover. I'm generalizing a lot of stuff, so yeah, all the really nice little details I'm going to skip over because I've only got 10 minutes. This is my name and my contact information at the bottom. I'm doing all kind of stuff, and if you want to know more or anything, you can reach me through these channels. What we really want to talk about is this: the general design of hyperscale, because it's a bit of different design compared to all the other stock keeping units you can get from Azure. When you're looking at the general provisioned serverless databases on Azure, they're all kind of designed the same way, and mostly because you've got little to no control of the number of files. When you're looking at the hyperscale one, they're all kind of different things. The most important one is that they're using page servers. And these page servers are holding the data cache, and there's a data file below it. So really nicely thought out, and it's working really fast. That's why a hyperscale can transfer data really fast and works quite quickly. One of the most important things is that the log service isn't. Yeah, it's part of the hyperscale, but it's not integrated. It's kind of asynchronous service. This means that your logging will not hit your performance as hard as it will on the other SKUs. It's got a stable one. I'm going to show you in the next slide. But the most important part was when we were deploying a data warehousing project. With all the other SKUs, we were hitting the log service way too hard because databases are in a full recovery model. So everything gets logged for the backup. And that really hit our performance. With this log service, it didn't hit it as hard or hardly. All right. The log I/O is stable. It's always 100 megabytes per second. This really helps with your speed. That was cool because that was hitting our processes. You can scale by query, but that's what most of the Azure databases can do. And we've got multiple files by default. So when you're deploying an Azure hyperscale database, you're getting multiple files, which means you get more parallel reading and writing processes. One thing you need to keep really in the front of your mind is once you've gone to hyperscale, you cannot upgrade or downgrade anymore. Once you're going hyperscale, the database SKU is fixed. So if you're thinking of trying it out, go ahead. But remember, all the data you've got in there, you need to find a way to get it out again. I'm working mostly with data warehousing. That means I can reload from the source systems without much of a problem. But if you're going OLTP for hyperscale, remember, if the data isn't in your source system anymore, it's only in the hyperscale, you need to find a way to get it out. When you're going in hyperscale, you can scale up and down. It's really cool. It scales in the background. So what effectively happens is the hyperscale service you're running keeps online until the new one is finished. So if you're running a 2-core hyperscale instance and you're going for 28 cores, 28 cores is being prepared. When it's done, it fails over and it's going to that one. The cool part is you can scale up as high as you want, or your credit card allows, to get all the performance you need. And once you're done, you can scale back. Can scale back down again to save you a lot of money. What you need to remember are two things. When you're scaling up and down, it's effectively a failover, which means a short break in the connection, and your tooling needs to support those connection breaks. Second one, there are a number of DMVs that are losing their contents because it's a failover. It's going to a new kind of instance. And a number of DMVs get reset to 0. One of those I'm a bit bugged about are the index usage statistics. So it's quite hard to find out if indexes are used or not. Of course, your costs are related to your running setting. When you're using Query Store, it's not impacted by the failing over. So all the contents are saved within the Query Store. When you're scaling up and down, especially when you scale up, please don't forget to scale down because it's quite an expensive database feature. I've mentioned a number of these things already, so I can move on to the next one. This is one important one I ran into. When you're going to restore a hyperscale database, you need to take a good look at this part. It's going to restore my database with a 16 vCore setting. If you just think, I'm going to restore it, click next, finish, you've got a 16 vCore database running. If that's what you're after, fine, go ahead. If that's not what you're after, you might run into quite a lot of costs, especially if you just want the contents of 1 or 2 tables. 16 vCores may be a bit over the top. Just keep that in the back of your mind. We had a bit of a bug, hit a bit of a bug, or a big bug, when we were testing out Hyperscale about a year ago. And it's a confirmed bug by Microsoft, by the way. We upgraded a general purpose database to Hyperscale, and the underlying design broke completely. We found out because we had a weird weight type, RBO RG storage, which isn't really all that nicely documented. But we found out mostly that all our performance was gone. What happened? We used to, when you're going to Hyperscale, you get a page servers and files, and they are somewhere around 128 gigabytes. We got one page server with 1 terabyte of data, and that didn't work at all. So when you're starting on a Hyperscale database, start from scratch. Create a new one, insert your data. Microsoft promised me they would fix this bug. The irritating point is I haven't had a large enough database yet to move to Hyperscale to test out if it really got fixed or not. If you want to know if you've run into this bug, usually you're going to the database properties and going to the file options. Thing is, on Azure, you haven't got the file options within your database properties. So you need to find write a query to get the data. When you're running this query, this is the output you want to see. We've got a number of database files, 128 gigabytes. This is the correct setting. You'll see a number of files that have got less data. It's got something to do with the design we've got with all the data and data distribution. But this is the result you're after. This is what you want to see. 128 gigabytes of data of multiple files. In the end, the question is, will you use Hyperscale? The thing is, you need to think about the use case you're having. When you're going into data warehousing, Hyperscale is a very good option because it's fast, it's got fast log I/O, and is running smoothly when you're lucky. If you're running an OLTP, you might need it, but maybe you don't need the big 24 core version. Maybe you can run everything with 4 or 8 cores. Thing is, it's your budget. You need to think about the costs it's incurring because Hyperscale is expensive. When you're claiming your database for 3 years, the pricing offer Azure has, there's a term for it and I can't get it in my head right now. But when you're saving your instance for 3 years, the cost will go down, and with Hyperscale, it will help you a lot, but still it's an expensive one. So you really need to know if it's the right fit for you. Business critical or general purpose sometimes are quick enough depending on the data you've got in it. But remember, it's your budget. Your budget, yeah, well, most CEOs don't like it when you're going over your budget. That was my talk, and I've spoken a bit quickly because I've got about 40 seconds left. If you have any questions or want to get into a discussion whether or not you should go into Hyperscale, I've got my Twitter handle there, LinkedIn. You can find slides on my GitHub, or you can send me an email on my business email. Thank you so much for joining me. Thank you so much for staying around for this session. And Magnus, thank you so much for organizing this one.
Thank you so much for doing it. It's the hardest format I know. Because you still want to pack a lot of information in, and doing it in 10 minutes is a real struggle, both in creating the presentation and actually delivering it. So thank you, Rates, and thank you to all of the 5 speakers. You did an amazing job. You kept the timing, you kept the presentations interesting, and if I had a hat, I'd take it off for you. Thank you so much for coming to SQL Friday Lightning Talk version.